Hey guys, this is the first video in the new series. We're talking about genetics now, looking at how DNA plays a role in what we look like and how our bodies look when we're developing. And everything is controlled by the DNA. And so this first podcast is going to be a lot of vocab. And I hate to throw vocabulary at you at the very beginning, but everything vocabulary in this particular chapter is going to be underlined. So looking here in your notes, right at the very top, I want you to make a list of traits that you have, and a trait would be something like I have brown hair, so that would be one of my traits. So yours are going to be different based on what you look like. I also have green eyes, if you can't tell. Okay, so take 2 seconds, make a list of your traits while I drink some water. Okay, now that you've made your list, what is a trait? The things that we just listed are physical characteristics, and that's what traits are. They are physical characteristics. So they are physical descriptors, might be another way to put it. So a trait would be something about I have light skin, or I have dark hair, or I have detached earlobes. If you look here, some people's are attached to their cheek. Mine are detached. I can roll my tongue. That's a trait. These are all things that I can do, physical attributes that I have. And all of this comes from your genes. It comes from your hereditary information. And we got to remember that the hereditary or the genetic information is found in the DNA. So everything we study for this chapter is going to relate back to DNA somehow. And the first thing we need to talk about are these things called genes. So in this diagram on your paper, this is a DNA section, so this is what the DNA actually looks like. Okay, so it's a twist, and if you look, I can't draw very well, but if you look closely, you can see the twisting motion that's happening there. And then these are chromosomes over here, so we're going to look at the relationship between DNA and chromosomes in just a second. In DNA, there are certain chunks of information that are part of the code. DNA is a code, just like in English we have codes. Writing is a form of code, and in certain pieces of the DNA, these are called genes. Okay, so the box above on the DNA strand is a special section called a gene, and genes code for specific traits. Okay, so if the trait is the physical aspect, the gene codes for the trait. So on the DNA strand, you have genes that are, so you might have one gene here, you might have another gene that starts a little bit later in the code, like over here. Okay, so this is a DNA strand. Remember, over here, these are chromosomes, and you have 23 chromosome pairs. And all of these genes come in pairs. Okay, you have 2 for every single trait. And one gene in that pair is called an allele. So here's a gene pair. Okay, these go together, or this is a chromosome pair. Let's say you have a gene right here in the chromosome. Okay, that little chunk of DNA is a gene. Now, these are identical to one another. They're the same. So the one on the left is going to be one allele, and this one on the right is going to be a second allele. Okay, so the blue equals the gene. Okay, this one is an allele. It is one of the 2 genes, and this one is also an allele. Okay, so again, DNA is the hereditary information. In the DNA, you have genes. Okay, in the genes, or those genes, one of the pair is an allele. So we're breaking it down further and further, with DNA being at top, DNA falling under that, and then an allele would be beneath a gene. So again, a lot of vocab coming at you today, so slow it down, and if I'm talking too quickly, you need to pause and go back and listen to it again. And not all alleles are created equally, so not all pairs of genes are created equally. The alleles of a gene, sorry, I missed the underlining there, are either dominant or they are recessive. Okay, so the alleles of a gene are either dominant or recessive, and a dominant allele is do this in blue. This is an allele that shows its trait whenever present. So, for example, dark hair is a dominant trait. So if I even have one allele, okay, I only need one. If I have one allele in that dark hair gene, I'm going to have dark hair. So my hair is very dark. That means I've got that dominant trait. People that have blonde hair, naturally blonde hair rather, that is a recessive trait. It does not show up. In order to see the recessive trait, you need to have two or a pair of recessive alleles to be shown. So blonde hair is a recessive trait. That means I need to have two blonde alleles when they pair up next to each other. So let me draw another chromosome in here. So we've got chromosome 1 and its partner number 2. Okay, and both of these have a gene. So let's say this one is the dark hair allele. Okay, it's dominant. All right, it falls under this dominant trait category. Even if the other one has a recessive, this will be light, because the dark is dominant, we're not going to see the light one. This blue overpowers, okay, we see the blue dark hair. The only time you would ever see a recessive allele is if you've got two, let me get some space, redraw my chromosomes. The only time you'd ever see a recessive allele is if you have two recessive alleles with each other. So this is light, okay, light hair. This is also light or blonde or whatever you want to call it. Because there's no dark gene overpowering them, we see the blonde hair. That's jumping ahead a little bit, but again, you got to understand the difference between dominant and recessive. If you have one dominant allele, it's going to dominate the trait. If you have two recessive alleles, it's going to be the recessive trait. So some of you at this point have already done that coin flip lab where you look at the heads versus the tails. That's what this is illustrating. So again, we've got a lot of vocab in here. Let me scroll up for you. So we're looking at DNA. Again, it's the hereditary information. Genes code for traits, and you have two alleles per gene. Okay, so again, DNA has genes, and there are two alleles per gene, and those alleles can be either dominant or recessive.